Physical Oceanography, the key to unlocking Earth's secrets.
How much are we using the vast ocean, often called a treasure house of resources? In fact, the ocean itself is a source of energy. Natural motions, such as waves and sea winds, can generate electricity. Deep beneath the sea lie abundant metal resources like manganese, nickel, and cobalt that are difficult to obtain on land. Much of the food on our tables, including fish and seaweed, also comes from the ocean. Despite all these benefits, how much do we really know about the ocean? The ocean never stays still. It flows continuously like a vast river. Yet, even this movement is often forgotten. Climate change often begins in the ocean, but our attention remains on the sky. While awareness drifts elsewhere, the ocean continues to shape Earth's climate and human life in profound ways. The field that studies this is oceanography. Physical oceanography is the field that studies physical phenomena in the ocean. The ocean is vast and constantly changing, so it provides essential information for accurate weather prediction. It plays a key role in observing and forecasting natural disasters, such as heavy snowfall, tsunamis, and typhoons. It is a study that reads the signals sent by the ocean. Because the ocean is vast and always changing, results can differ even in the same experiment. For this reason, a theoretical approach is important in physical oceanography. Physical laws and mathematical theories that apply to the ocean, such as fluid dynamics, are used to explain invisible flows. Recently, advances in computer technology have made it possible to conduct much more precise research using complex numerical models. Physical oceanography is gradually uncovering the secrets of the ocean. Why is seawater salty? Because many substances are dissolved in it. The most familiar is sodium chloride. When 1 kilogram of seawater evaporates, about 35 grams of solid material remain, and about 80% of that is sodium chloride. Differences in salinity and temperature change the density of seawater. These differences create large-scale flow, called ocean currents. Ocean currents transport heat and materials, regulate the Earth's environment, and move heat from low latitudes to high latitudes, warming the planet evenly. The ocean also absorbs carbon dioxide. About 90% of the carbon dioxide produced by human activity is taken in by the ocean. How does the ocean absorb it? Carbon dioxide in the air dissolves directly into seawater, or plankton near the surface absorbs it. If the ocean absorbs so much, why does atmospheric carbon dioxide keep increasing? Because human emissions rise faster than the ocean can absorb them. When the balance breaks, change builds quietly. Increased carbon dioxide causes global warming, which can alter ocean currents and lead to more frequent extreme weather. The ocean is not just a collection of water. It is a vast system that constantly interacts with the atmosphere. A clear example is the El Niño phenomenon. For a long time, fishermen in Peru noticed that the sea became warmer every few years. This change often appeared around Christmas, so it was called El Niño, a Spanish term meaning the boy, referring to the baby Jesus. In the equatorial region, warm seawater normally moves westward with the wind. What happens when the wind weakens? The warm water that stayed in the west shifts eastward, pushing the air above the surface upward. To fill the gap, the flow of wind changes again. As a result, warm water gathers in one place, creating the El Niño phenomenon. Without physical oceanography, we might still view such changes as folklore. The ocean still holds many secrets, and what is known is only a small part. The key to revealing this unseen world is physical oceanography.